Given that dy dx equals 2x plus 1 times y, which of the below is a possible solution for y of x? Okay, so normally we don't see the y and the x on the same side here. So one of the clues is you don't want them on the same side. You want them on opposite sides. Hence the separation of variables. So the idea here is get all the y's on one side, get all the x's on the other side, and integrate. So let's do, let's do 1 over y dy equals 2x plus 1 dx. Now this is how you do separation of variables, and it's not 100% correct. This is almost more of a mnemonic on how you solve the problem, but pretend that you can take dy and dx and move them apart. It helps. Okay. Integrate both sides, like so. You still get points on pretty much any class you're going to be in. Once you get past, I guess, probably third semester calculus, you might have classes where they actually care about breaking apart dy dx, but not this class. So this is fine. Okay, so then we have natural log of y, because the integral of 1 over y will be natural log of y. And we have the integral of 2x plus 1, which would be 2x squared over 2 plus x. And then we have, let's see here, we're trying to find which below is a possible solution for y of x. Okay, so we're trying to solve for y. So then this would cancel. And so we would have y equals, natural log of y equals x squared plus x. And I will rewrite this slightly. So equals x times x plus 1. Maybe. So I'll take both sides to the exponent. So y equals e to the x times x plus 1. And so now we have a solution for y. So we have, interesting. Okay, so y equals e to the x plus 1 right here. So that's a possible solution. X squared plus x. Yep. And the others are, nope, these are all wrong. But it's kind of interesting with this 0 right there. So let's take a look at this solution here. So one of the things I was kind of, I'm not lazy, but negligent with was, all right, so we have our integral both sides. We have x squared plus x over here, and then we'll add c. You should always, the c is supposed to be there. It's a constant that you get from integration. And you might be like, well, we should have a c on the left side too. Well, we do. So you could have plus c1 here, plus c2 here, and then we could move the c1 over, and we just get c2 minus c1, which we just call another c. And so, even though I'm kind of dismissive often of constants, what we should remember then is when we take both sides to e to the natural log of y to get y, and we take the other side to the exponent of e, we have e to the x squared plus x plus c. Well, this can then be rewritten as a constant 1e to the x squared plus x, because we can pull out the c make it e to the c, which is just another constant. And so we get what we'd get then, we'd have a general formula like this, where c1 would be c1 times, we get the constant multiplied by the exponent. And when you see it in this way, it's like, okay, it makes sense that y could equal 0 because c1 could be 0. And so, yes, this would be the correct solution right here. And the way we'd solve this would be separation of variables. So to backtrack, look back at what we did briefly. So we have a derivative equals this. We see that x and y are both on the same side. And so one of the things we want to do is we want to separate those apart from each other and then integrate both sides and then solve for y. And that is the technique called separation of variables. You might sometimes go over that towards the end of your calculus class, your second semester calculus. You probably won't see this on the AP exam, but you never know. And it's good to kind of have an idea of how this works anyway. So that is the general basic idea for separation of variables.